as Braden and Megan were saying, we're studying the effects that the photon pressure from the sun has on an asteroid and how it perturbs its orbit. So our pressure is proportional to the radius squared, and it's defined as L naught times 1 plus alpha over 4 pi r squared c, where this is the solar radiance, albedo just being how much is reflected off the asteroid at any time, and c being the speed of light. We can multiply across the area to get that the force is equal to L naught times 1 plus alpha surface area over 4 pi r squared c. Now combining this with the gravitational force, we get that the net force is equal to gmm over r squared plus all that now, using the definition of force being the negative derivative of potential, we can say that this is all equal to our potential. And I'll define this quantity as lambda. Now we can set up our Lagrangian. And then use the Lagrange equations to receive our equations of motion. Del L by del theta is equal to 0. We can equate that to d by dt of del L del theta dot, which is equal to d by dt of mr squared theta dot. So, because this derivative of this is equivalent to 0, we know that this is a constant, which we'll define as Lz. Now, for the radial Lagrange equations, we can say that del L by del R is equal to m over 2 2r theta dot squared, 2's cancel, and then minus lambda r squared. And then for del L by del R dot, that's equal to mr dot. We can equate these two signs to get this is equal to r theta dot squared plus lambda over mr squared. And then going to the definition of energy we defined in class, being the quantity del L by del theta dot plus del L by del R dot equal to energy. We can just plug in these terms, removing the d by dt, which will, through some pretty messy cancellations, end up giving us that E is equal to m r dot squared over 2 plus LZ squared over 2 mr squared minus lambda over r. Rearranging for r dot by itself, we get that r dot squared is equal to 2e for m plus lambda over m minus LZ squared over 2mr squared and by applying both the chain rule to this side and the substitution of, because I made the wrong substitution last time and had to go back, and I don't want to eat into my group members' time, so I'm just going to skip ahead to what the final equation is. It's that 1 over r theta is equal to m lambda over LZ squared times 1 plus epsilon cosine theta. M, lambda, and z are all based on the initial conditions. And then epsilon here is just the eccentricity of the orbit. When it's between 0 and 1, it'll just be a, or when it's 0, it'll just be a circle. When it's between 0 and 1, it'll be some sort of ellipse. And once it gets beyond or equivalent to 1, it'll start becoming ejected from the system.